Okay, so how did you get to that information? How did you decide on that? So you're saying in this first graph we have more spread out here. Okay, so there's some light, mediums, and darks. What happens in the second graph? Very good. So she's read her graph well. She has light and dark are basically gone, and it's just medium. Okay, you picked B. You said they changed their color to become medium gray. When we talk about natural selection, though, is it an individual changing their color? It's the population over time, right? So, if you had to refine your answer to change it, what would you change? What makes the most sense based on talking about evolution by natural selection? Okay, D. Why did you say D? How does that make sense? Very good. So she's seeing that the ash here is going to change the color of the island in some way. Okay. And that over time, because of that, these insects are going to blend in better than the other 2%. Does that make sense to you guys? Most of you had that when I came around. So I don't have any questions on that. All right, what we're going to do, go back to the station that we left at. You only got about half your time there. Okay, we're going to do 3 more rotations to finish that up. All right, I'm going to be cycling around to you guys just like we used to. So they're normally balanced. Think about when a cheetah's running, they're turning that tail so it pulls their body going in a different direction. It kind of adjusts their spine. That makes sense? We were thinking maybe not running to balance. Alright, I know some of y'all are still finishing those up. That's okay. If you weren't here yesterday, you can catch up at another point. Go ahead and rotate clockwise for me. Rotate clockwise. Y'all are doing awesome. I really appreciate Brandon and Angelica coming in today, jumping right in, even though they weren't here yesterday. Alright guys, what I want you to do over here is, for these first 2, there is a correct answer, but that's not what it is. I want you to go through and hypothesize which one of these embryos matches up with each organism, and then as you get to the next page, it'll become more clear. Does that make sense? Okay, so that's the discovery you're trying to do there. Make sure you start on first page. Alright, so on this one, this is the trickiest one normally for people. You have these 6 figures. Okay, these are 6 different parts of organisms, but they all have the exact same number of bones, and the bones are structured in the same way. So what that lets us know is at some point there's a common ancestor in the bone structure. However, over time, we notice these are all very different, right? And they have very different functions. The first thing you're going to do on your chart here is you're going to tell me what's the function of each one of those body parts for those organisms. So for example, a human, what's our arms for? Picking stuff up, right? What's our whale going to be used for?
What's that swimming?
For swimming, right? Very simple. So you're just going through and telling me those functions. Here, you're telling me the differences that you notice between the whale and the human, the cat and the human. So you're looking at these bones and just telling me the most obvious thing you see is different. So let's do one that I haven't done with people. You do the bat and the human. What's an obvious difference you notice there between those two? The fingers are longer, okay? So you would tell me that for the bat, and then you go over to this part, and you would tell me why is it important for the bats to be longer than the humans? And I know you're with me when I'm saying. Okay, to fly. What do bats have? They don't have arms, they have wings, right? So these need to be really long and stretched so they can fly. Does that make sense?
Yeah.
You guys got it.